Assalamu alaikum and a very good morning to all. Today we are going to start with the same chapter, behavior of metals, with a new unit, that is metals in competition. So in the very first, in the previous unit, what we studied about the reactivity. We studied about some reaction of the metal with the HCl and with water molecule. You can see over here what we did. We studied the reaction of the metal with water, and then we studied the reaction of the metal with hydrogen chloride. But today we are going to check the competition or the competitive behavior of the metals with one another. Now the very first competition which we are going to analyze, which we are going to test, that is of the carbon let's have a look. It's first with the magnesium, and then we are going to study about the competition of the other metals, that is with oxygen. And in the upcoming slide we are going to study about the competitive behavior of the metals inside the solution, like how they replace one another inside the solution. And then we are going to end up this topic with that. We will say that all these reactions, this competitive reaction of between the metals, they are the redox reaction. And then sir is going to tell you about the reactivity of the metals in your Uzbek language. Okay. So the very first slide is a competition of the carbon with the magnesium oxide. You can see over here we have taken a crucible. What is crucible? Crucible is basically a pot. What this is a pot. Okay, in this pot what we have taken, you can see these black particles. These black particles are basically the magnesium. These are the magnesium. We reacted this magnesium, we heated up. When you will heat it, this heat will provide what? Oxygen. So magnesium is going to react with oxygen, and as a result what will happen? Magnesium oxide is going to be produced. Magnesium oxide is produced. Now to this magnesium oxide, which you can see over here, we will add what? We will add a carbon powder. We will add a carbon powder. So what happened? Now we are going to analyze magnesium oxide O2 reacted with the carbon. Yes, we can have this magnesium can be in the two form. Either you can, like magnesium react with oxygen, it gives you what? Magnesium oxide in this form. But in this case what you will do, you will put 2 over here. Fine. And in another form you can also have magnesium that react with oxygen O2 to produce magnesium O2. So 2 types of magnesium oxides are produced. Fine. Okay, now this magnesium oxide is going to react with a carbon powder. So now we are going to check whether carbon metal is more reactive in competition or magnesium is more reactive. So what we found that no reaction was possible. This gives us an idea that magnesium is not detaching this oxygen. It is not allowing this carbon to attach with oxygen to produce carbon dioxide. This gives us an idea magnesium is more reactive. It is more competitive than the carbon in this reaction. In the second case, you can see magnesium oxide is mixed with a powder carbon and heated. No reaction was found. So magnesium must be more reactive than carbon. In the second case, you can see we have taken these light purple. You can see these are the lead beads. These are molten. What does this molten mean? Molten means like when you will provide them heat, it's going to be easily melted out. Now we took this lead and we heated up. When we heated up, and lead oxide was produced. Now to that lead oxide what we add carbon. So now this lead, it start reacting with the oxygen. So as a result what was produced? Lead oxide was produced. Lead oxide O2. Now to this lead oxide what you are going to do, you are going to put some carbon powder and you have to analyze the reaction. So what I have found, this was replaced. You can see lead oxide was taken and it reacted with the carbon. So it produces what? Carbon dioxide. The oxygen get attached to the carbon. Oxygen get attached to the carbon, and this metal lead was left as in a metallic form, in a solid state. So what we analyze, this gives us an idea, lead is more reactive than the carbon is more reactive than the lead in this competition. Now When lead oxide is used instead, it turns to molten lead and carbon dioxide gas was formed. So carbon is more reactive than lead. The same was done for the other, for calcium, aluminum, zinc, iron and copper. What we found, calcium oxide was changed into carbon dioxide and calcium metallic was produced. Aluminum oxide was changed into carbon dioxide and alumina metal was produced. Zinc oxide, iron and copper, you can say they do not react with the carbon. They were least reactive than carbon and these were more reactive. So the oxides of metal like calcium oxide, aluminum oxide, zinc oxide, iron oxide, copper oxide, which are mentioned over here, they were all tested with the carbon powdered and two were found to be more reactive, these two, calcium and aluminum, and the other three, the zinc, iron and copper, they were least reactive than the carbon. They do not show any sort of a reaction. Okay, so they do not show any sort of a reaction and they were replaced and they produces what? Carbon dioxide gas when they were reacted all with the carbon powdered. Okay, now over here they have discussed the very first reaction of the lead oxide with the carbon. So this gives us an idea that carbon is more reactive than the lead. Now here lead oxide has lost its oxygen. So what has happened? Oxygen over here was in -2 and lead over here was in what? In a +2 state. So over here the lead is changed into what? 0 state, and here -2 for 2 -4, and carbon is in what? In a +4 state, and carbon here is in the 0. So this gives us an idea that lead from +2, or you can say the lead from +1, for 1 that will be +1, it changed into what? Lead 0, changed to lead 0. This gives there is what? A gain of electron. What? A gain of 1 electron. This gain of 1 electron. So whenever there's a gain, that means the reduction has happened, that is reduced. Carbon over here, it is acting as a reducing agent. This is an agent, this is a helper which is helping in the reduction of the other. It is providing what? The electron. So it is giving what? An electron to this lead. Now the reaction is, you can say it's a redox because there's a loss and gain story. Carbon is more reactive than some metals. From what? From calcium and aluminum, it is what? Calcium and aluminum are more reactive, but carbon is more reactive than zinc, iron and copper. Now it will reduce their oxide to form metal. You can see over here what has happened in this reaction. This carbon has reduced the metal oxide to what? To their metallic form. It has reduced their oxide to the metallic form. Like the lead oxide, PbO, is changed totally into Pb. Okay, now let's move to another competition. It is basically the competition of the other metals with other metals for oxygen. Over here what we have taken, we are taking copper oxide. We are taking copper oxide and we are analyzing it with the zinc, with iron and with the lead. Now some powder iron is heated with a copper oxide. So they are saying whether this iron will grab this oxygen from copper oxide or not. So what happened, what we analyzed, when the reaction gives out heat, there was what we found, there was an heat coming out. This gives us an idea. This is an exothermic reaction. This is what? This is an exothermic reaction. The heat was given off from this spot, and when reaction gets going, the mixture was glowing, brighting. You can say some shine was coming out from this beaker, from this pot, and iron 2 oxide was produced. The iron which was placed, it was totally changed into iron oxide, and a copper was left as a metallic. So this means iron has grabbed, it has stolen, it has taken the oxygen from the copper oxide. The same happens for the other metals were also compared in the same way. Like we took zinc and we mixed that with a copper oxide. We took iron Fe and we mixed with a copper oxide, and we took lead Pb and we mixed with the copper oxide. And what happened, what we found, all of them, they change into what? They change into lead oxide and Fe3O4 and zinc oxide, and in all of them copper was left as in a metallic form. Copper was left as a metallic form, you can see over here. But what you can find, lead was a bit slow, then iron was a bit slow, and in this competition the zinc won the race. Zinc was very fast, then iron, and then lead, and in the last the copper was very least reactive, you can say. Now over here they have discussed, they have taken iron, they have reacted with the copper oxide, so this iron catches the oxygen and a copper is left as in the metallic form. The test confirmed that iron, zinc and lead are all more reactive than copper. Now the iron here is acting as a reducing agent. How? Because iron here is in what? It is in a zero state. It is in the zero state. Over here in a -2 and iron is in a +2. So when iron changed from 0 to +2, this gives us an idea there is what? There is loss. There is what? There is loss of how many electron? 2 electron. These electrons are lost. So reducing agent is an agent which help in the reduction of the other, and itself is what? Oxidize. Itself is oxidize. There is loss in itself, and to other metal it has given provide electrons. So you can see over here oxygen was in a -2 and copper was in a +2 state. Okay, in a +2 state, and over here the copper is in the 0 state. Okay, now over here you can see from +2 the copper is changed from +2 to 0. This means there is a gain of 2 electron. Now the same what I have explained, Sir Hamza is going to explain it in Uzbek. Sorry, I was just teaching it in English. You can, sir, start from here.
Assalomu alaykum hurmatli o'quvchilar. Bugun biz sizlar bilan metallar o'rtasidagi raqobat, ya'ni metallarning faolliklari haqida gaplashamiz. Xo'sh, Miss Noyob xonim sizlarga hozir ingliz tilida bu mavzuni tushuntirdi. Bu mavzuni tushuntirdilar. Xo'p, metallar turlicha faollikka ega, ularni o'sha boshqa moddalar bilan ta'sirlashishda mana shu metallarning faolligi alohida ahamiyat kasb etadi. Demak, mana bu rasmga e'tiborimizni qaratamiz. Bu rasmda magniy oksidi hamda uglerod moddasini o'zaro kimyoviy ta'siri haqida gap ketdi va bu ikkalasini o'zaro qizdirgan paytimizda hech qanday kimyoviy reaksiya sodir bo'lmadi. Ya'ni bundan biz qanday xulosa chiqarishimiz kerak? Magniy metali uglerodga nisbatan kimyoviy faolligi yuqori. Shuning uchun u o'zidagi kislorodni uglerodga bermayapti. Ikkinchi rasmimizda esa biz qo'rg'oshin 2 oksidi bilan uglerodning o'zaro aralashmasini qizdirgan vaqtimizda, demak, qo'rg'oshin zarrachalari ajralib chiqqanligi mana bu rasmda ko'rsatilyapti. Ajralib chiqishini bildik va bundan xulosa chiqardikki, uglerod qo'rg'oshinga nisbatan demak kimyoviy faolligi yuqori va shuning uchun demak qo'rg'oshinni uni birikmasi tarkibidan siqib chiqaryapti. Mana bu joyda shu jarayon reaksiyasi berilyapti. Qo'rg'oshin 2 oksidiga uglerod ta'sir ettirilyapti. Reaksiya natijasida qo'rg'oshin hamda karbonat angidrid, ya'ni uglerod 4 oksidi hosil bo'lyapti. Ya'ni bu yerda uglerod qo'rg'oshinga nisbatan faol bo'lganligi uchun qo'rg'oshinning o'rnini egallayapti-da, qo'rg'oshinni siqib chiqaryapti. Va biz bu reaksiyadan quyidagi xulosani chiqaramiz. Qo'rg'oshinga nisbatan uglerod faolroq, lekin magniyga nisbatan uglerodning faolligi past. Umuman mana shu jarayon oksidlanish qaytarilish reaksiyasi deb ataladi. Bu yerda qo'rg'oshin +2 oksidlanish darajasidan 2 ta elektron olib 0 oksidlanish darajasiga tushyapti. Uglerod esa 0 oksidlanish darajasidan 4 ta elektron berishi hisobiga +4 oksidlanish darajasiga o'zgaryapti. Kislorodlarning esa oksidlanish darajasi o'zgarmayapti. Ya'ni bu yerda qo'rg'oshin elementi oksidlovchi vazifasini bajaryapti. Uglerod elementi esa qaytaruvchi element vazifasini bajaryapti. Bu reaksiyaning umumiy nomi esa oksidlanish qaytarilish reaksiyasi hisoblanadi. keyingi bo'limga o'tamiz. Bu yerda demak rasmlarga e'tiborimizni qaratamiz. Demak, mis 2 oksidi bilan temirni aralashmasi qizdirilish bizga ko'rsatilyapti. Demak, mis 2 oksid va temir aralashmasi qizdirilgan vaqtda bu yerda reaksiya natijasida temir oksidi bilan mis hosil bo'ladi. Demak, jarayon o'sha yorqin alanga ajralib chiqishi hisobiga boradi va biz bu jarayonni kuzatishimiz mumkin ekan. Va shu jarayonda temir elementi misni o'rnini egallayapti. Mana bu reaksiyaga qaraydigan bo'lsak, ya'ni bundan xulosa chiqarishimiz kerak. Temir misga nisbatan kimyoviy faolligi yuqori va shuning uchun ham demak misni uni birikmasining tarkibidan siqib chiqarayotganligini ko'rishimiz mumkin. Umuman mana bu rasmga e'tiborimizni qaratamiz. Bu yerda rug', temir, qo'rg'oshin va mis elementlari berilgan. Shu joyda mis elementini faolligi qolgan 3 ta metalnikiga nisbatan eng passiv ekanligi yoki rug' metalli esa qolgan uchalasiga nisbatan kimyoviy faolligi eng yuqori ekanligi aytib o'tilyapti. Va o'sha mana shu rug', temir, qo'rg'oshin elementlari mis oksididan misni erkin metal holigacha chiqarib, o'zlari esa oksid hosil qilishini bu yerda ko'rsatib o'tyapmiz. Umuman bu jarayonda issiqlik ajralib chiqqanligi uchun egzotermik reaksiyalar deyapmiz. Umuman reaksiya vaqtida issiqlik ajralib chiqsa, bunday reaksiyalar egzotermik reaksiyalar deyiladi. Agar reaksiya vaqtida issiqlik yutiladigan bo'lsa, bunday reaksiyalarni endotermik reaksiyalar deb aytamiz. Again, continue.
Okay, now we'll continue further. Okay, we are done till here. We were discussing in this reaction in which we are basically doing a reaction of these two metals, one of the iron and second of the copper with oxygen. We are competing these two metals, the iron and copper with oxygen. So what we found, iron over here, this is acting as a reducing agent. Reducing agent is an agent which is helping in providing the electrons to the copper. Copper over here, it was having 2 electron not available with the copper. So the iron, it provided the 2 electron, and as a result, copper changed into 0 state. And the iron here, it was all of its electron was with the copper, but now iron is having deficiency of 2 electron. You can see over here there is a loss of 2 electron which are eaten away by the copper. So whenever there is a reduction reaction, whenever there is a loss of electron by any sort of a metal, that reaction is going to give out the heat. That reaction will be an exothermic. You can see some light, some heat is coming out of the spot. So we will conclude that all the reduction reactions gives out heat. They are exothermic in nature. Now we'll continue further. Now we're going to analyze the competition of the metals inside the solution. Now you can see this is a beaker, and in this beaker we have placed a copper sulfate solution. We have a copper sulfate solution. You know what is the formula of copper sulfate? This is copper SO4. Now in this copper sulfate solution, whenever you have a copper sulfate solution with a hydrator with a water molecule, it is blue in color. This is what it's blue in color. You can see here it's blue in color. So now they are discussing, we have placed an iron nail here in this beaker into this copper sulfate solution. So will anything happen to this iron nail? Yes. What happened? A coating of copper on iron happens. A coating of copper happens on this iron nail. From where this copper comes? From this copper sulfate solution. Copper sulfate was inside the solution, so that copper get attached to the nail, and the iron of this nail that moves to the solution. You can see there is a kind of displacement reaction. You can say displaces. If we have a displacement reaction here, copper moved to the iron nail and this iron, it moves to the sulfate solution. So iron sulfate is basically green in color. Now the solution is going to be green in color. That will be what? That will be green. And this was first blue. It was first what? Blue in color, but now it is green in color. And the copper from a -2, copper over here was in a -2, and sulfate is in a it is in a -2, and copper is in a +2 state. So the copper changed from +2 to 0. It means the iron has provided its electron. Iron over here was in the 0, but now over here the sulfate is in -2 and iron here is in the +2. This means iron has lost its 2 electron. So now what they have written, once again, iron wins against the copper. It displaces the copper from the copper sulfate solution. All other metals also displaces the less reactive metal in the same way. You can see we have a zinc, iron, copper and silver. So zinc will win this competition. It will replace into zinc sulfate here, and the copper will be deposited on the iron nail or on the zinc nail. If we have an iron nail, so that will be changed into iron sulfate, and the copper will deposit on the that nail. If we have a copper nail, so the copper will move to the copper sulfate, and that copper, if it is like it is, if the nail is made up of an iron, and inside the solution we have a copper sulfate, so the iron will move to the into the solution, and copper will deposit on the iron nail, and silver is the least reactive of all. Other metals and solution were tested too, with the result above. What do you notice about the other order of the metal in this list? So this gives us an idea that zinc is the most reactive inside the solution. A metal displaces a less reactive metal from solution of its compound. So a metal, like for example, if you take an iron, so this iron is going to replace this copper sulfate, which is the least reactive. Copper is least reactive and iron is more reactive from the solution of its compound. So this is what they have discussed in this slide. Now sir is going to explain in your Russian language.
Eritmalardagi metallarni aktivligi haqida gaplashamiz biz sizlar bilan hozir. Xo'p, mana bu rasmga e'tiborimizni qaratamiz. Bu yerda mis sulfat tuzi eritmasi ko'k rangda berilyapti va shu mis sulfat tuzi eritmasiga temir mixni solyapmiz va ma'lum vaqtdan so'ng o'sha temir mixning yuzasi qizil rangga kirganligini ko'rishimiz, ya'ni mis zarrachalari bilan qoplanganligini ko'rishimiz mumkin. Xo'p, buni xulosa chiqaramiz. O'sha temir metali mis metaliga nisbatan faol bo'lganligi uchun mis sulfat tuzidan siqib chiqarayotganligiga e'tiborimizni qaratishimiz kerak va bu jarayon mana bu reaksiya yordamida ko'rsatilyapti. Temir metali mis sulfat eritmasi bilan ta'sirlashyapti va reaksiya natijasida mis sulfat eritmasi hamda qattiq holatdagi mis ajralib chiqayotganligini ko'rishimiz mumkin. Bu yerda o'sha eritmani rangini o'zgarishiga ham e'tibor berishimiz kerak. Dastlab o'sha mis sulfat eritmaga ko'k rang berib turgan bo'lsak, keyin temir 2 sulfat hosil bo'lishi natijasida eritma rangi yashil rangga o'zgarayotganligini ko'rishimiz mumkin. Xo'p, bu yerda temirni oksidlanish darajasi 0 dan +2 ga o'zgaryapti. Misni oksidlanish darajasi esa 0 dan +2 dan 0 ga o'zgarayotganligini ko'rishimiz mumkin. Bu yerda temir 2 ta elektronini mis metaliga beryapti va elektron berayotganligi uchun u qaytaruvchi bo'layapti. Mis metali esa temirdan 2 ta elektron olyapti va shuning uchun u oksidlovchi bo'ladi. Ya'ni qaysiki element oksidlanish qaytarish reaksiyasida o'z elektronini bersa, u qaytaruvchi bo'ladi. Qaysiki element reaksiyada elektron olsa, u oksidlovchi element bo'ladi. Mana bu diagrammada rux, temir, mis va oltin, kumush metallari berilyapti. Bularning ichida rux metali eng faol ekanligi, kumush metali esa eng passiv metalligini kuzatishimiz mumkin. Ya'ni bu joyda o'sha rux temirni, misni va kumushni birikmalaridan siqib chiqara olishini aytib o'tishimiz kerak. Kumush esa ularni, ya'ni rux, temir va misni birortasini birikmasidan siqib chiqara olmaydi, chunki uning kimyoviy faolligi eng passiv bo'lganligi uchun.
Okay, thank you, sir. Okay, now we will continue. Now they are ending this topic that all these competitive reaction of the metal with other metal, or a reaction of the metal with oxygen, or a competitive reaction of the ions inside the solution, all of these reaction are what? These are the redox reaction. Now in all these reaction there is a loss and gain story. Now you can see we are going to we have a complete equation for one of the competitive reaction of a metal with another metal, and we are competing it with oxygen. So we have analyzed over here in this reaction that iron is more reactive than the copper. Now why? Because the iron has replaced the copper and it has changed into iron oxide, and a metallic copper is left behind. Now if we checked this iron competition with the other with the copper inside the solution, so we are basically analyzing, we are checking its competitive behavior of the ions inside the solution. So what we found, we took an iron and we placed in a copper sulfate solution. So what we found, again this iron was more reactive than the copper. It replaces this copper with the iron sulfate, and what we found, okay, the solution was blue in color. It was what? Blue in color, and now the solution color is changed into what? Green. So this gives us an idea, okay, iron is more reactive than the copper, and copper is changed into a metallic copper in a solid form. Now if we study about their half reaction, half equation, this is for the electron loss and this is for the electron gain. So in the very first half reaction, iron has lost its 2 electrons, so it's changed into +2 state, and the same 2 electrons are then taken by the copper and changed into a metallic copper. In this case you can see the same happens over here also. Iron lost 2 electron. The loss of electron is written here on the, you can say, the right side of the equation of half equation, and the gain of electron is written over here. So so copper over here gained 2 electrons, changed into a metallic 0 state. Now if we discuss both the reaction, the net ionic equation, so what we can do, we have to eliminate the electron lost and gain. So iron here, that will give its 2 electron to this deficient +2 copper. The iron will change into a deficient body +2, and copper will change into a 0 oxidation state. Over here the same happens as it happens over here. Now what we are concluding, in each case the iron has given up electron to form positive ions, and copper has what? Accepted electron to form a copper. So more reactive metal, what it will do, it will create a positive ion that will do what? That will do a reduction. There is going to be what you can say, there will be a loss of electron by the reactive metal species, and it will be converted into a positive ion more readily, more fastly, more quickly. This was the end of the chapter of this unit, metals in competition. We studied about the competitive behavior of metals with one another, with oxygen or with the ions in the solution, and sir will explain this in the your Uzbek language, the reactivity of the metals, and we will recontinue this reactivity of metal in our upcoming unit. In the new unit you can see the reactivity series. Now this is your homework, and you are going to submit the homework in the PDF form on your Google Classroom. I hope so you have understood. Thank you so much and goodbye.
Xo'sh. Yuqoridagi reaksiyalarning hammasi oksidlanish qaytarilish reaksiyalari hisoblanadi. Bu haqda hozir ingliz tilida Miss Nayob sizlarga tushuntirib o'tdi. Bu jarayonni demak qanday tushunishimiz kerak? Masalan, o'sha temirni mis oksidi bilan reaksiyasi natijasida temir oksidi va mis hosil bo'lyapti. Bu jarayonda demak oksidlovchi va qaytaruvchi elementlarni, qaysi elementlar ekanligini bilib olishimiz kerak. Qaysiki element reaksiyada o'z elektronini yo'qotsa, bu element qaytaruvchi bo'ladi. Hozir bu yerda qaytaruvchi element temir elementi bo'lyapti. Qaysi element reaksiya vaqtida o'ziga elektron biriktirib olsa, bu element oksidlovchi bo'ladi. Bu jarayonda demak mis metali oksidlovchi bo'layotganligini ko'rishimiz mumkin. Ya'ni ingliz tilida bu jarayonni demak for electron loss bu qaytaruvchi elementga taalluqli, for electron gain bu oksidlovchi elementga taalluqli bo'lyapti. Mana bu oksidlanish jarayonini demak mana bu ko'rinishda yozamiz ekan, qaytarilish jarayonini esa mana bu ko'rinishda yozamiz. Ikkalasining farqiga e'tibor beringlar. Qaysiki element elektron yo'qotsa, strelkadan keyin elektron yo'qotayotganligi ko'rsatiladi. Qaysiki element o'ziga elektron biriktirib olsa, strelkadan avval o'sha elektron biriktirib olishini ko'rsatib o'tiladi. Xo'p, temirni mis sulfat eritmasi bilan ta'siri bu reaksiyada ham o'sha eritma rangining o'zgarishi bu joyda kimyoviy reaksiya sodir bo'lganligini bizga bildiradi va shu bilan birgalikda mana shu ikkita reaksiyadan umumiy reaksiyani ionli ko'rinishini yozadigan bo'lsak, mana bu ko'rinishda, demak ikkalasida ham bir xil ko'rinishda yozishimiz mumkin bo'lar ekan. Xo'p, mana bu metallarning aktivlik qatori hisoblanadi. Bu yerda metallarni biz aktivlik qatorini kamayib borish tartibida joylashtirganmiz. Ya'ni litiydan boshlab toki oltingacha bo'lgan metallarning qatori. Va mana shu qatordagi metallar demak 3 guruhga bo'linyapti. Aktiv metallar, o'rtacha aktiv metallar va passiv metallar. Aktiv metallar odatdagi sharoitda suv bilan ta'sirlashib, metal gidroksidi hamda vodorod gazini hosil qiladi. O'rtacha aktiv metallar suv bilan yuqori haroratdagina kimyoviy reaksiyaga kirishadi. Reaksiya natijasida metal oksidi hamda vodorod gazini hosil qiladi. Passiv metallarimiz esa suv bilan umuman ta'sirlashmaydi. Qizdirsak ham, odatdagi sharoitda ham, qizdirganimizda ham umuman ta'sirlashmaydi. Va bu yerda yana bitta narsani aytib ketishimiz kerak. Bu yerda eng faol metal litiy hisoblanadi. Demak, u o'sha o'zidan keyingi turgan barcha metallarni ularni birikmasidan siqib chiqara oladi. Eng passivi esa oltin bo'lyapti. Oltin hech qaysi metalni uni birikmasi tarkibidan siqib chiqara olmaydi. Sababi oltinni demak o'sha aktivligi eng past bo'lganligi uchun. Bu haqda demak keyingi darsimizda yana biz sizlar bilan davom etamiz. Bu uyga vazifa. Demak, uyga vazifada sizlarga 6 savol berilyapti. Demak, mana bugungi darsimizni biz tugatdik va o'sha mavzumiz bo'yicha berilgan savollarni yaxshilab diqqat bilan o'qiysizlar, ularni tushunishga harakat qilinglar va shu savollarga javob yozib bizga, demak, e-mailimizga javoblarni yuborsalaringiz, biz uni tekshirib sizlarga baholarni qo'yib borishimiz kerak bo'ladi. Ko'rishguncha, xayr.